Hello. Okay, so I shower, I ate, and I went ahead and looked up this condition a little bit more. I feel like my explanation before was a little bit all over the place. So I found this awesome journal or this awesome publication in the Journal of Hematology and Oncology. The authors are in the bottom right of this slide, and I think that helped me understand a lot more about this condition, hemophagocytic lymphohistiocytosis. And this graph, I love this figure. It was part of the publication and pretty much explains the disease a little bit more. So I'm going to just go over these. I just have a couple slides that it really helped me understand better. So here, the green cell, the big one on the top left, is a natural killer cell, or is representing a natural killer cell and cytotoxic T cells. So these cells normally secrete perforin and glycine, which is enzymes that pretty much help regulate the target cells. And that's very important because the target cells are the ones that are going to be part of the immune response of the body when we have viruses or tumors or bacteria, and we don't want that immune response to just be activated all the time. So the natural killer cells control these. Well, in this case, for this condition, they're not controlling those target cells. They're not regulating the target cells. So like you see in this loop, the target cell pretty much continues to be active and continues to activate the T cells. And we have a lot of interleukins, interleukin 1, interleukin 6, interleukin 18, TNF alpha being produced and producing this cytokine storm, which is a hyperinflammatory state in our body. And of course, we know the body does not like to be in a hyperinflammatory state. And this is the big problem with this condition, that it's a cytokine storm, everything is inflamed, the immune response is just extremely active, attacking everything because it doesn't have any regulation. And like we see in this graph, from the natural killer cells and from the T cells, there's the interferon gamma that is activating the macrophage. And that's going to be important for the next slide. But remember, the interferon gamma to the macrophage, and then the macrophage producing all these interleukins that are pretty much like a cytokine storm, producing a lot of inflammation in the whole body. This could be caused, I know in my previous video I said multiple myeloma, and that is correct. But it's not just that. It's not just a plasma cell malignancy. Really, infections can cause this, malignancies can cause these, viruses, bacteria, but even chemotherapy. So like I talk in my patient, the patient had chemotherapy, and then we started seeing all these things, and he went into organ failure, and nobody really understood what was going on until one of these physicians said this patient has HLH, which was kind of amazing. I mean, I'm excited to learn about this. But okay, so this is a little bit more about the condition. And let's talk a little bit more about how we recognize it and how we treat it. Okay, so I don't want to make it too complicated, but pretty much there's a few red flags, like I talked before, that for pretty much anyone working in hematology, oncology should keep an eye on. So fever, falling blood counts, and raised ferritin. So very three different things. We have a lot of patients with fever. Of course, we think sepsis, we think chemotherapy fever, neutropenic fever. When we have falling blood counts in oncology patients, that's another thing that we're kind of like, okay, well, that happens all the time, right? Like after chemotherapy, we have our nadir, when we have thrombocytopenia, neutropenia. But remember, fever, now we have falling blood counts. Of course, I will be thinking neutropenic fever maybe, but now raised ferritin. That's a strange one. Three red flags. Then we go to the evaluation of HLH. So if you have those three things, start thinking a little bit farther. Okay, go ahead and do fibrinogen. Check your electrolytes, your triglycerides, because triglycerides will be very high. I know a lot of people have cholesterol and high triglycerides, so sometimes we don't really think that will be something significant, but in this condition, that's very important. High triglycerides, high LDH. Check the renal profile, liver function test. The liver enzymes will be extremely high as well. And then, of course, if you have time, do a bone marrow biopsy. Check for CD25 on natural killer cells, and assess for splenomegaly. This could be through a CT scan, but that's a little bit more in depth. But you can really just start with fibrinogen, electrolytes, simple blood tests that could tell us quickly if the patient is in this condition, HLH. If, according to these guidelines, on this graph I found in the Journal of Hematology Oncology for this disease that was published, if you meet 5 out of 8 of these criteria, you can determine that the patient has HLH. And then the H score, it has to be greater than or greater or equal than 168. And I don't want to complicate this too much, but on the right, you can see on those blue columns the criteria, the scoring, and kind of like how many points each thing is. So we have the fever, the splenomegaly, cytopenia, which could be like thrombocytopenia, neutropenia, ferritin. So kind of like an easy criteria. And then another thing, and I don't want to go too in depth with this either, but that is kind of important that I learned reading this article was that you can have primary HLH or you can have secondary HLH. So primary is actually familial, so it's genetic. So I think that's what the doctor was talking about, that there's a test that you can send out. I think pretty short. She meant the familial HLH. Like you see on the top, on the bottom left, the FHL1, FHL2, those are different things that you can check for the familial type, so the genetic type. There's X-linked as well. So different tests, different syndromes, disorders that can be related to HLH. But secondary is one that we're more concerned in hematology oncology, really, because this one is the one that can be produced by bacteria, parasites, can really seem very similar to a neutropenic fever or a patient with a liver malignancy. So very, very interesting, very important to keep keep thinking that, it could be the chemotherapy, but it could also be HLH. So the triggers for HLH, hematologic malignancies, like we had a patient with multiple myeloma, solid tumors as well. So it doesn't have to be hematologic only. It can be tumors like breast cancer, prostate cancer, any solid tumors, because those cause a lot of inflammation in our body. And it can also be produced by chemotherapy. So, I mean, this patient that we had, he did have multiple myeloma, but also the interesting thing was that once we give him the first dose of chemo is when he really just went out of control. So I think this was really something that the chemotherapy produced. But I guess we're still exploring. But anyways, I learned a lot in this condition. Oh, one more thing. The treatment, of course, because it's autoimmune, it's a hyperinflammatory state. Of course, steroids will help, like the doctor told us. Steroids, dexamethasone, you can start giving that for a patient to control that hyperinflammatory state. But I also learned in this article that the only approved targeted therapy is called imapalumab, which is a target for the interferon gamma. And I don't know if you guys remember, but on the previous graph, that was the interferon gamma was the one that was kind of like promoting the macrophages to produce all those interleukins. So if we block that or we target the interferon gamma, pretty much the signal for the macrophages to produce all those interleukins for the cytokine storm is reduced or blocked. So that's the only approved therapy so far. And again, these This article was published in November of 2024, so maybe there's something new coming up, but that's what I learned today. I hope this helps, and I'll be posting more videos of things that I learned. Bye bye.